Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 98, I chat with Sean Olive, the Director of Acoustic Research at Harman International, about how to listen to sound systems and subjective listening versus objective measurements. So stay tuned.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded February 6th, 2012. Episode 98. Listen up! This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, or TV instantly. All streamed directly to you, saving you time, hassle, and money. For your free 30-day trial, go to netflix.com/twit. Hey there, Scott Wilkinson here, online editor of HomeTheater.com. This week's guest geek is Sean Olive, the Director of Acoustic Research at Harman International. And we're going to be talking a lot about listening to music and sound systems and subjective versus objective experience and measurements and so on. Lots of interesting stuff today. Hey, Sean, welcome to the show.
Ooh. Hello, how are you, Scott?
I'm great, thanks. Thanks so much for being on.
Oh, my pleasure.
Those who are tuned into the live video stream at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Sean, and I'll pass along as many as I can. So, Sean, when we met, it was at the multi-channel listening lab at Harman International, which I found to be a fascinating facility. I'm going to talk about that in a minute, but really the purpose, the foundation of that place has to do with having trained listeners listen to different speakers and evaluate them from that perspective. And it got me to thinking about the difference between trained and untrained listeners. Give us a little bit of background on that whole concept. How do you train yourself to be a listener?
Sure. Well, yeah, the idea that we use trained listeners was somewhat controversial among other industries where they typically use consumers, 300 or 400 listeners, consumers that is the targeted customers. So by using trained listeners, the challenge was, are these listeners biased? And if that's the case, then we're designing products that may suit the taste of a trained listener, but not necessarily the consumer. So basically, we select our listeners based on their hearing. They have to have normal hearing. And then at that point, we've developed some software where they go through a series of exercises that teaches them how to evaluate different attributes of sound quality, how to discriminate, and the software automatically adjusts to their ability. And as they get better, it shows up. And when they get to a certain level, they're considered trained. So that's how we select our listeners, based on how well they do in these software exercises. And then, of course, we monitor their performance in every test that they do. And so one of the first things we did many years ago is that we ran over 300 listeners from outside Harman through a loudspeaker test that we did here. And then we ran our same trained listeners through the test, and we compared their performances and their preferences. And what we found out was that when you look at the results, essentially the untrained listeners were selecting the same loudspeakers based on preference as the trained listeners. What was different about them really was the degree to which the trained listeners were more discriminating and more consistent. And we found that the untrained listeners, they tended to rate things higher on the scale. But essentially the rank order was the same for both trained and untrained listeners.
Mm-hmm. JC in the chat room says, is this similar to music appreciation training? And it was actually a question I was going to raise as well.
Not really. It really has nothing to do with appreciating music. In fact, they listen to very short loops over and over again, and we simulate distortions, spectral distortions, dynamic distortions, and the task is really to identify these distortions, and then if the task is to rate them, they have to rate them consistently. So after a while, there's very little, the signals, because they're so short and repetitive, they're actually not, they're the opposite of being very musical. But to a trained listener, they just sound like pink noise, and they use them to interrogate the loudspeaker if that's what they're evaluating. And we don't really select them based on how musical they are.
Mm-hmm. And how does this training affect the listening experience? Say, for example, when you're outside of the evaluation phase in the multi-channel listening lab, for example, and you're just at home listening to music, you as a trained listener, how does your training, your ability to discriminate different types of distortion or so on, affect your listening experience when you're just listening for pleasure?
Well, it basically ruins your life. Believe me, early on in my career, I listened. I did a study with Floyd Toole on the detection of resonances, and after we were measuring the threshold, the absolute level at which you can just barely detect something, and once you become attuned to these things and you can hear them, you hear them everywhere. And you become very fussy as a listener and hard to satisfy.
You know, I have often been asked, as a trained musician myself, the difference between being a trained musician or not being a trained musician when listening to music, and do I hear things differently? And I think trained musicians do hear things differently. And I'm not sure I would say it exactly ruined my life, but it certainly changed the way that I perceive music. I was at a LA Phil concert recently with an untrained listener, and she asked me, how does it affect you? And I said, well, I can hear, for example, that the second bassoon is a little flat. Mm-hmm. And she said, I didn't hear that. And I said, no, don't imagine you did. But it does change. I'm much more analytical about things. It's a little more difficult, I think, for me to get lost in the music than it is for an untrained listener. And I suspect the same thing would be true in this case.
Yeah, and it's interesting. A lot of people think that we should use trained musicians to evaluate our products because, logically they would be the most critical listeners. But it turns out that musicians are, among some of the worst listeners. I wouldn't say they're among the worst, but what happens is they become involved in the music and they're not really listening to the sound quality differences. So we've seen this, and other researchers have shown that musicians aren't necessarily the best listeners until they've gone through some critical listening, and then they start to perform just like any other critical listener.
This relates to a question that iPad 32025 in the chat room has. Does the degree to which the listener enjoys a song affect perceived quality?
I don't think so. I think initially when listeners aren't trained, the music and how much they like it is a factor. And certainly the biggest complaint we get about our listening test for new listeners is the music. But through training, they, like I say, the music just becomes pink noise. It becomes a test signal. And the better that signal is at revealing problems, the more efficient and the easier it is to do your task, which is to listen critically to the audio product and come up with a list of problems or attributes.
Right. Now, the training program that you have put people through used to be not available to the general public. You could only go through it by going to Harman in L.A. and going through a training process. But now, if I'm not mistaken, you've made that program available as a program online. Is that correct?
Yeah, that's right. About back in February, we put a beta version of the software, which we call How to Listen, and it's available on I'm on a blog that I created called harmanhowtolisten.blogspot.com. So you can download a copy. There's a Mac version as well as a Windows version, And we've actually, one of the issues we had to deal with was putting music packaged with the software. We didn't have, license and the right permissions.
Oh yeah, of course, to put music in there. So what did you do?
Yeah. Well, we talked to a local record company, Bravura Records, and they're known for right now creating a catalog of 24-bit, 192 kilohertz sampled albums. So he gave us some very high quality music. The engineer is Bill Schnee, and he's well known. He's won many Grammys, and he created these tracks and basically allowed us to use them royalty free for the purposes of educating listeners.
Wow, that's really great. And I assume that the clips that you use have to have some particular characteristics in order to be useful in identifying certain properties of the sound system, right? So you got to have something with very high frequencies, mid frequencies, low frequencies, and so on.
Right. And that's a good point you raised, because early on, years ago, we looked at 20, 30 different tracks, and we actually, through the listener training, found that people did very well on some of these tracks, and other tracks they did very poorly. So based on the feedback from the listeners, we actually picked the tracks that have the most revealing of spectral problems in this case. And it turns out that in order to hear these spectral problems, as you said, you need the very lowest frequencies, the very highest frequencies, and everything in between. And pink noise turned out to be the most revealing track. Of course, most people don't want to listen to pink noise, but the next best thing after pink noise was Tracy Chapman, Fast Car. So she's the next best thing to pink noise.
I do remember listening to that at the MLL actually. So you guys have been using that one for a while. Nerve in the chat room says, if we go through the training, does it really mean that we'll not enjoy music? No, that does not what that means.
No. No, I mean, I still, I'm a musician, and I still go to Disney Hall once in a while and enjoy what I hear. I'm not sitting there critically, listening to resonances.
Right, exactly. Speaking of the MLL, or Multi-Channel Listening Lab, it's a fascinating facility that is at the Harman International Campus here in LA, where you put several speakers on these pneumatic trays, and they get shifted around behind an acoustically transparent screen, so you can't see which one you're listening to. It brings up the question of blind versus sighted listening tests. And you conduct your tests blind, that is, the listeners can't hear which speaker they're listening to. And not only that, but the position of the speaker changes so that its positional location does not affect the sound. What are your thoughts on blind versus sighted listening? Why do you conduct your listening tests in a blind manner?
Right. Well, doing any kind of psychological experiment, the basic tenet is it should be blind. And it's a protocol used in testing drugs, pretty well anything when there's a potential bias or placebo effect. So early on in my career, when I first joined Harman, of course, there was a lot of resistance to doing these sorts of tests, because up until that point, everything was done sighted. And usually it was between the engineer who developed the product as well as the marketing guy. So there was a lot of resistance. So the first thing I did was set up a test where we had 4 products, and the test was done with 40 employees, and they did the test blind, and then they did the test sighted. And it turned out that there was a significant difference in the preference ratings between these two types of tests. In the case of the sighted test, the ratings for the big expensive products went up, and in the sighted test, the inexpensive product that was made out of plastic, the scores went down. And we found, this was back in the days when we didn't have a speaker mover, so we would set the speakers up side by side in the room. And we found in the double-blind tests, when we moved the speakers around, the scores would change. In fact, the position alone had about a 25% effect on the ratings. So position was a big factor in these tests. And we also found program interactions. In other words, your preference rating for the loudspeaker would change as a function of program. And this was all very visible in the blind test, but when we actually did the test cited, the positional effects disappeared as well as the program interactions. So people weren't responding to real changes in the sound caused by position and program when they could see the loudspeakers.
So just to get back, sorry, go ahead, finish your thought, please.
I was just going to say, so that paper, we published it in the Audio Engineering Society, and after that point in time, all the tests done on Harman were double blind. That was about 1994.
Yeah. Dark in the chat room says, it sounds like the improved perception of the same wine when it costs more.
Right.
Same sort of deal. In fact, I don't know if you've ever seen, there's a show on PBS, I think, called Vine Talk, where they have several celebrities trying different wines and coming up with their favorites, but they do it blind. So this is another example of how blind testing really gives you a more accurate result.
Right. Same thing.
Yeah, same thing. Alex in the chat room just asked regarding the listening program, how much does it cost? I think it doesn't cost anything, right?
No, it's free.
Yeah. And how long does it take to go through the training?
It all depends on how often you use it, but if you do a half an hour of training a day, I think in a month or two, you're probably going to get up to level 8. And level 8 is the minimum level that we require for our listeners before they're accepted into product tests.
And can anybody, if they can demonstrate a proficiency at that level, come and participate in product tests, or do you have to be a Harman employee?
Well, if you live in the neighborhood in Northridge, we would certainly include you in some tests and show you how well you did.
Great. Bruce S. asks, sorry, go ahead.
Oh, I was just going to say that this is something that we do routinely. We will compare the results of our trained listeners to people from outside, just to sort of calibrate and make sure that we're not fooling ourselves by using trained listeners.
Nerve in the chat room asks, have others in the industry begun to adopt this sort of methodology?
I would say the adoption rate is still very slow. There's some companies who claim that they do blind tests, but they're few and far between. And one of the reasons is it's expensive to do these tests. Training listeners takes some time to build a room with a speaker shuffler and put all the proper controls in place is not an exercise that doesn't cost money.
Well, sure. The multi-channel listening room with the speaker shuffler thing that I described, that had to be pretty darn expensive to build.
Right. That was over $100,000, and that was maybe 15 years ago.
Right. Bruce S. asks in the chat room, can a golden-eared listener learn to pick out characteristics of certain products? I would think golden ears might have an easier time.
Well, you have to define what a golden ear is. And in my experience, there's a lot of self-proclaimed golden ears. And when you actually put them to a test, it may turn out that they're not so golden ear. They may be closer to a tin ear or a rusty ear.
Joel H. in the chat room asks, would a blind or sight-impaired listener actually tend to do a better job?
Well, that's an interesting question. I don't think there's a lot of data on that really to tell us what the truth is. But Floyd Toole back at the National Research Council used to have a friend who was blind, and he would participate in these tests, and it turned out that he didn't perform any better than a normal a person with sight. And,
they didn't perform any better.
No. But of course, that gentleman was a little older. So one of the issues is as you get older, your hearing deteriorates, and that can be more of a factor than say whether you have good eyesight or not.
Right. And so, of course, does your program, by the way, do any kind of hearing test to begin? I mean, that really needs to be done by an audiologist to get a reliable result.
Right. So, no, it doesn't do any audiometry. So we have an audiometer here on staff. We have an audiometer on site, and we do audiometry tests on all of our listeners. And if we see any issues, we send them to their doctor.
We've been talking a lot about subjective versus objective. We have been talking about subjective really up to this point, and I wanted to get into objective measurements as well, and the relationship really between subjective experience and objective measurements. In particular, you brought up in our conversations before the show a couple of things. For example, subjective versus objective evaluation of room correction systems. Right. We've got Odyssey, we've got Trinoff, we've got a number of companies like Pioneer and Yamaha that have their own proprietary room correction systems with their audio-video receivers, for example, or pre-pros. What have you found in your studies in terms of subjective versus objective evaluation of these systems?
All right. Well, one of the first questions, the basic questions we asked was, do these various commercial room corrections actually make it sound better or worse compared to not having any at all? So about 2 years ago, we went out and got several of these commercial room correction devices, and we did some double-blind tests where we took a speaker and a subwoofer, we set it up in our reference room, and closely following the manufacturer's recommendations, we basically calibrated each system, and then we brought in listeners and we did a blind test where they would compare the original speaker and subwoofer with no correction to these various commercial implementations. And it turned out that about 3 of them actually made a significant improvement to the sound. One of them did no better than the subwoofer and speaker without room correction, and one of them actually made it significantly worse. So, so to my knowledge, that was the first study that had ever really done any double-blind tests of these room correction devices. And and then we did some objective measurements in the room at the seats, and we found that there was a pretty good correlation between what listeners preferred and how it measured in situ. So that was encouraging.
Have those results been published?
Yeah, we gave a preprint at the Audio Engineering Convention, and if you go to my blog, you'll find a copy of the PowerPoint presentation showing the results.
And your blog is, give us the URL for that.
Yeah, if you just type my name, Sean Olive, it's actually up on the, I can see it in front of me, seanolive.blogspot.com.
Ah, okay. A very interesting blog, by the way. I recommend it to everyone listening. You get into all kinds of great stuff in that blog, so well worth reading.
Yeah, thank you.
Well, before we go on, I do want to take a moment. We've got a lot more to talk about in terms of audio. But before we do, I want to take a moment to thank our sponsor for this episode, which is Netflix. Now, of course, all of our listeners and watchers, viewers here on Home Theater Geeks probably already have Netflix in your Blu-ray player, in your TV, certainly on your computer, your game console, maybe even your iPad or iPhone, Android phone. It's available on just about every consumer electronics device these days and easily piped to your home theater. And you can watch thousands of TV episodes and movies instantly with the streaming feature, which is what I use. And, you can start on one device, finish on another device. You can basically get anything you want as soon as you want. Talk about instant gratification. And it only costs you $8 or $9 a month. And you can download or stream as much as you can possibly consume. For TWiT listeners, there's a free 30-day trial. You can go to netflix.com/twit and start that 30-day free trial. And believe me, I did, and found it highly valuable to find stuff that I wouldn't otherwise be able to find on disc or certainly broadcast. So to watch those thousands of TV shows and movies instantly with no hassle, saving tons of time and money, go to netflix.com/twit for that 30-day free trial. And we thank Netflix for their support of Home Theater Geeks and the TWiT network. So another aspect of the question of subjectivity and objectivity is in loudspeaker specifications. And I have to say that I'm always pretty skeptical about the specifications that I read about loudspeakers. And we do our own set of measurements on the speakers that we review. But of course, you guys have an even much more elaborate setup to do that. Do you find the specifications that loudspeaker companies put out, not counting Harman, of course, to be meaningful in any way?
Not at all. In fact, I think Floyd Tools put it aptly. He said there's more useful information on the side of a tire than there is on a loudspeaker specification.
So what's the problem? Why can't manufacturers come up with meaningful specifications?
Well, what they typically show is a spec 20 hertz to 20 kilohertz, or maybe 50 hertz to 20 kilohertz, and they'll, you're lucky if you get that, and they may put a tolerance on that, plus or minus so many dB. But the problem is it references a single curve, right? It could probably be the on-axis curve, and when you put a speaker in a room, you hear a combination of the direct sound, which is typically on-axis if you're sitting on axis, but you also hear many reflections, and those are all produced off-axis. So to really characterize the sound quality of a speaker, you need to have a set of measurements that shows you what the direct sound looks like in terms of frequency response. You need to see what the first reflections look like, what the sound power looks like, and maybe even the directivity index. And
I'm sorry, what was that last one?
The last one would be the directivity index. So that's
directivity. Yeah.
Right. So that would be a measure of how directional the speaker is as a function of frequency. And, that's a standard measurement that we produce whenever we're designing a speaker. And it's come to the point now where I've come up with a model that will apply statistics to that graph, and we can predict the preference rating in a listening test with about a correlation of 0.86, just based on that graph alone. So that's a pretty accurate predictor of how the speaker sounds. And that information is available today, but virtually no manufacturer supplies that information with their product. And if you had that graph, you could basically, even a naive person could look at these graphs and pretty well pick out a good speaker from a bad one.
How does Harman handle this? I mean, there are several speaker brands within Harman, of course. There's Revel, there's Infinity, JBL. Do those brands publish more meaningful specs?
No, that's a good question. In our JBL Professional, if you go to their sites, you'll find these comprehensive measurements on the studio monitors like the LSR series. But in consumer, it's a slow process. One of the issues is that the marketing people think we would have to educate people what these graphs mean. Secondly, it's not very meaningful unless you can compare to the competitors, for example. So I think
that's true.
So as an industry, before we start publishing these curves, we'd have to educate people and explain what they mean, or we could go one step farther and just translate these graphs into a single metric, or maybe two metrics that the consumer can understand. Mm-hmm. Like a scale from 0 to 10, for example, where 10 is the very best and 0 is the very worst.
But as you say, if other manufacturers don't publish similar specs, then making any kind of comparison based on that is going to be useless.
Right. So there is some activity within the Consumer Electronic Association, for example, and there's some manufacturers who are trying to come up with a spec very similar to what we do here at Harman, based on these measurements. But it's a slow-going process because To do these measurements, you need an anechoic chamber, and you need the test equipment. And for some manufacturers, that's an expensive proposition. And so they're trying to modify it, compromise it to the point where it's not meaningful. So we either need to find a third party facility that could do all these measurements, or the manufacturer is going to have to invest in the equipment in the room that allows them to do these measurements.
And now Canada has such a facility. You worked there yourself, the National, Research Council? National, I forget exactly what it's called, but you worked there, Floyd Toole worked there, Paul Barton works there at PSB Speakers.
Right. Both Floyd and I came from there, and they have an anechoic chamber, and they provide all these measurements as a service. I think it's a minimal cost. It might be $300 or $400 to have a speaker tested. And in fact, I think Soundstage magazine uses this facility in Ottawa to measure and review speakers. So you can actually find some of these measurements online.
Beatmaster in the chat room brings up an interesting point regarding the effect of an AV receiver having to share power for the different channels or not. In some cases, the receivers and power amps have discrete power amps for each channel. That must affect the results that you get as well, what electronics you're using with the speakers.
Yeah, we don't use receivers typically when we're testing speakers. We'll have a dedicated amplifier for each speaker, and the amplifier is of course identical. So those kinds of issues are not a factor in our speaker tests.
Yeah, but then how reflective is your result then of the real world situation where most people are in fact going to be using AVRs? I guess it's impractical to try and replicate that situation because there are so many different possibilities.
Right. I mean, just the music alone. If you put on your favorite track and it's not a very accurate or neutral music track, then that, of course, is going to influence your opinion of the loudspeaker. So, yeah, there's the room, there's the music, there's the amplifier, and we just try to control those variables as best we can.
F-Loop in the chat room asks, or comments here first, Harman's research seems to say little about harmonic distortion, but we all know that running a tweeter too low or a small woofer too low and loud makes for poor sound. Does Harman's subjective testing department provide any advice to design groups regarding harmonic distortion?
Yeah, I mean, that's a good question. A few years ago when I was doing a study on predicting loudspeaker based on measurements, I looked at total harmonic distortion, and the correlation between harmonic distortion and preference was very poor. It was almost zero.
Really? Yeah. Wow, I'm surprised.
Yeah. I mean, there is some correlation, but it's not really a factor in most of our tests unless you're testing products where you're just testing them at their limits. It turns out, that other people have found this as well. Harmonic distortion alone is not a very useful indicator because a lot of the distortion is masked by the music. So you could have a situation where you could actually have higher harmonic distortion. It would sound better than a situation where you had lower harmonic distortion. So I think one of the biggest areas of research that we need to do is to come up with a perceptually meaningful specification for nonlinear distortion. I
would agree. Now, before we get to the end of our time, I know that you sent a PowerPoint over to John, our engineer, and there was one graphic that we looked at before we actually went on the air here, which was some sort of graphic about trained versus untrained listeners. And before we finish up, I did want to see that graphic, and if John can pull it up, that would be really great, because it had some sort of indication of the difference between trained and untrained listeners. Give us a little bit of explanation of what that graphic tells us.
Okay, so what we did was we looked at the performance of listeners based on two criteria. The first one is how discriminating they are. So if they tend to separate these speakers on a preference scale wide apart over a large range, then they're obviously more discriminating. And the second criteria is just how consistent they are. And based on those two criteria, we use a metric called the loudspeaker F statistic. And we looked at the F statistics of trained listeners and untrained listeners, and then we normalized these groups of untrained listeners to the trained listeners based on that statistic. And it turned out that after trained listeners, the most, based on performance, our retailers were the most best performing listeners. I think
the retailers, really?
Yeah. They were about 35% as good as a trained listener. And then the next, yeah. So that was encouraging because, these are the people that sell our products, and, they're good listeners because I guess through the course of their jobs, they do a lot of listening and a lot of, it actually pays off.
Wow.
The third group were the audio reviewers. We brought in, I don't know if we told them at the time that we'd be showing this data, but they were about 20% as good as a trained listener.
How interesting. I'm a little embarrassed for my profession, but...
Well, it was... I think as a group, they were probably had the most to lose, and they may have been a little nervous, so we should have probably brought them in again and retested them. But and then after that, the next group was our own marketing and salespeople, and they scored about 10% as good, if I'm remembering correctly. Mm-hmm, and prior to my involvement in testing, these were the people that were voicing the products, and it turned out that they were not the best ears.
Well, it certainly means to me, getting back to my group, my cohort, that I'm going to encourage my colleagues to go through this testing program that you now have online, which anybody can check out. So and download and run. And I'm glad there's a Mac version too, since I'm a total Mac guy.
Good.
One more question before we go. Which is another point that you brought up in our discussion before the show, and it's something that I've talked to a number of other guests about, which is how do we get young people to appreciate higher quality than they're probably used to with low bit rate MP3s and crappy earbuds? Those of us who are in my industry, and yours too, I'm sure, are concerned that youngsters coming up simply don't know what good sound sounds like and won't seek it out, won't buy products that provide superior sound quality, which might spell doom for our entire industry. What's your take on that?
Yeah, well, this has become a question that's asked a lot lately because a couple of years ago there was a big media blitz where there was a study done by Professor Berger at Stanford University. It wasn't a published study. It was just an informal study, but nonetheless, it got widely reported and went viral. And basically, the conclusion he made was that over time, these kids in college at Stanford University were preferring low-bit MP3 over the original lossless CD version. So this had a big ripple effect through the industry. People said that's the end of fidelity. We had customers in the car industry who were saying, well, since kids don't like good sound, we should, why do we need to put tweeters in the car? Can't we reduce the content? And even in our company, we had marketing people questioning the value and merit of using trained listeners and designing products that sounded good, because they said the evidence indicates that kids don't like good sound. In fact, they may prefer bad sound. So this led to me doing a little study. It was a very small study where I brought in some high school students, and they compared MP3 to CD. And it was a blind test, and it turned out that they preferred CD most of the time. In 67, 68% of the trials, they preferred CD over MP3 at 128. And then I ran them through a speaker test, and it turned out that they preferred the most accurate neutral loudspeaker in the group. And we've since we've run college students now, 40 college students, and we're getting similar results. In fact, they're a little more discriminating, perhaps, because they're a little older and more experienced. So
your results completely contradict the results of this other study that got so much press and attention.
Exactly. We found no evidence of teenagers or college students. Not one of them had a preference for MP3 over CD.
Speaking of headphones, we had a question in the chat room. It's now scrolled past my window. Does Harman test headphones at all, like you do speakers?
Yeah, we do. A lot of the testing right now is done over in Vienna, Austria, where AKG is located. And here in Northridge, we want to get more involved in the actual subjective testing, because I think headphones, compared to loudspeakers, headphones, I think, is about 10, 15, at the same period in terms of scientific research, about the same place where we were 15 years ago with loudspeakers. If you look at the standards for headphones, they're based on a diffuse field calibration, and there's papers now showing that may not be the right curve that we should be calibrating our headphones to. So, and if you start measuring consumer headphones, you'll find that they're all over the map. So clearly, different companies have different ideas of what an accurate headphone should be.
Mm-hmm. So sorry, go ahead.
Oh, I was just going to say, and of course, there are companies who don't think accuracy or neutrality is the target. I mean, there's clearly some headphones out there that have way too much bass, for example.
Right. Well, we have a sibling website, innerfidelity.com, and the editor, Tyle Hertzens, has been on the show a couple of times, and he does some pretty nice testing. He's got an isolation chamber and a really high quality dummy head, with good modeled ears, and he puts the microphones in the ears and the headphones on the head, and can get some pretty good results with that. So I'm really glad he's doing that. So how can we get youngsters? I mean, you've exposed some number of high school kids, some number of college kids to higher quality sound at your facility, but how can that exposure be widened to a greater audience?
Yeah, well, I think it's a matter of education, really. And the problem is, kids today, unlike when I was a kid, you could go into a stereo store, and the salesman would do A/B comparisons, and it became readily apparent that there were large differences between these different speakers, for example. So with headphones, people are buying them over the internet. Same with loudspeakers. There's very little opportunity to do a real A/B comparison, and so I think.
Well, plus retailers are kind of going away to some degree, also.
Well, exactly. It's become a big box internet sales model, business model. So I think, for example, either the Audio Engineering Society or maybe the industry needs to do some kind of education program where kids can either go to websites and hear demos of MP3 at different bit rates, for example, or just teach, this idea of having good specifications that are perceptually meaningful would allow kids to, just look at graphs and see this headphone sounds good, this one doesn't sound good. But, I think we're a long way from there, because even though we have objective measurements on headphones, we don't have a lot of listening test results from headphones. And, one of the challenges is, how do you do a controlled double-blind test on a headphone?
Are you working on developing a protocol for that?
Yeah, we are, actually. We basically, this is a joke. Well, one of the issues, I was going to say, we anesthetize the subject from the neck up, and then we blind. But, one of the issues is, they can see the headphone as well as feel it. So that's a bias in and of itself. So
makes it very difficult to do. Yeah, exactly.
Exactly. So if you look in the literature, there's few and far between listening tests that have been published on headphones and that don't have this bias in it.
Well, we've come to the end of a fascinating hour, and I thank you so much for being a guest on the show. Sean Olive is the Director of Acoustic Research at Harman International, and you can find Harman at harman.com, of course, and Sean's great blog at seanolive.blogspot.com. Thanks, Sean.
Thank you, Scott.
So you can find me online, of course, at hometheater.com. You can follow me on Twitter at htgeekscott, and you can email me at scott@twit.tv. Next week, my guest geeks are scheduled to be Jason Hartlove and Jeff Urich of Nanosys, a company that is working on a brand new display technology which relies on nanotechnology and quantum dots. So we should have quite a fascinating discussion then. Sure hope you'll join me. Until then, geek out.